This problem is about equivalent runoff coefficient, where the area and runoff coefficient of different types of land use will be given, and you have to find the equivalent runoff coefficient. So how to solve this type of problem? As you can see that here in this problem, the equivalent runoff coefficient is required to be calculated, where the area and runoff coefficient of different types of land use is already provided. In this case, there are 4 types of land use, and corresponding area of that type of land use within the watershed is given. For example, road type land use is 8 hectare in that watershed, whereas lawn type land use is 17 hectare, residential area is 50 hectare, and industrial area is 10 hectares. So suppose if this is the watershed, then some part of it is road area, suppose this is the road area, then some part of it is lawn area, correct? Some part of it is residential area. Suppose these are the part where the residential area is there. These are all residential areas. And some part of the watershed is industrial area. Generally industrial area. So in this single watershed, and of course the river is like this. Blue color indicates the river with this tributaries and distributaries. These are all the path of rivers. So you see, within this single watershed, there are 4 different types of land use, and each of the land use, of course, will have their own runoff coefficient. As you know, road areas are totally impervious. That means after rainfall, no water can infiltrate in the road area. So that is why you see uh, this C for road is 0.70. That means 70% of the water gets flow down or flow away from the watershed due to the imperviousness of the road. Again, lawn area, here infiltration occurs. So lawn area means grassy land, and what after falling water can infiltrate. So that is why you see 90% of the water is retained in the watershed. Only 10% of water goes away. In case of residential area also, the imperviousness is more than lawn but lesser than road. So that is why 30% water goes away and 70% water remains in the watershed. But whereas industrial area, which is totally impervious, so 20% water only stays in the watershed and 80% of the water goes out. So 0.80 means 80% of the water is runoff. 0.70 C equals to 0.70 indicates 70% of water is runoff. Runoff means that part of water which doesn't stay in the watershed, it flows out. As it cannot infiltrate, the water get out of the watershed and mixes with the main river or the path or the tributary and distributary of the rivers. So now how to find the equivalent runoff coefficient? We know that these are the land uses, these are the area of those land uses, and these are the runoff coefficient of corresponding land uses. The formula for finding the equivalent runoff coefficient is this, where what we do is we multiply the runoff coefficient with the area of the corresponding land. Suppose road area is 8 hectares in the watershed. The runoff coefficient of road area is 0.70, right? So we multiply each other, then we add the product value or at the result of this product with the multiplication of the area of lot type land use 17 hectare and its corresponding runoff coefficient 0.10 hectares. Next is residential area. So multiply area runoff coefficient 50 into 0.3. And then again the last type of land use, industrial area, 10 hectare into 0.80 runoff coefficient. Now you will say, what is this A? This A is the total area, which can be equals to this one. So N is the total number of land use. In this case, in our case, there are 4 different types of land use. So N is here, in our case 4. And so the total area is 8 plus 17, 85 hectares. So you just divide this entire numerator by the total area. So the total area is 25,785 hectares. Okay. So the result will be, the result of this equation will be just multiply 8 with 0.70, multiply 17 with 0.10, multiply 50 with 0.3, and multiply 10 with 0.8. You will find and divide the summation by 85 hectares. 85 hectares is the total area, as I have shown you. 8 plus 17 plus 50 plus 10. Okay, so the result will be 0.36. That means 0.36 is the equivalent runoff, and which was found out by multiplying the area of different land use with their corresponding runoff coefficient and adding the product with each other in the numerator and dividing the numerator by the total area. In this case it is 85 hectares. So once you do that, your C or equivalent runoff coefficient will be estimated. In this case, this is 0.36. That means it indicates that overall, in an average, 36% of the water that falls onto the watershed is converted to runoff. That means nearly 64% of water stays in the watershed. If you deduct 0.36 from 1, then it is coming as 0.64. And this is the part that stays in the watershed. Okay, so 64% of the water stays in the watershed, and rest, that is 36%, is converted to runoff. Okay, so this is the way you have to solve or you have to find the equivalent runoff